Now we have Shai, who's going to be engaging us with a wonderful talk about debugging Kubernetes in production. Shai is a developer advocate at Lightrun and is also a major open source contributor who has led some key global projects around the world, which I'm sure he'll be willing to touch on with you later. He's worked in most major industries, including sort of gaming, banking, and insurance, and medical. His talk is going to sort of cover why debugging is twice as hard as writing the code in the first place, specifically in obviously Kubernetes. So Shai, welcome to the stage. Would you like to do any extra introductions before you jump in, or are you ready?
I have a slide for that, so thank you.
Perfect. There you go.
Thanks, Henry.
Well,
yeah, it's standard, you know.
Yeah, absolutely. Yeah. Well, I'll leave you to your presentation. Looking forward to hearing more about debugging Kubernetes.
Great, thank you for that introduction. Let's start with that. Again, thanks, Henry, for the introduction. I'm, as we said, Shai Almog. Today, we'll talk about debugging at scale in production, specifically about Kubernetes debugging. I'm assuming in this talk that everyone knows the basics of Kubernetes, so I will dive right into the basic problem description and then into the 3 tools that I will show today. But first, a few things about me. As we said, I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and currently work as developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. I also have a series of videos on my Twitter account called 140-second Ducklings, where I teach complex things in 140 seconds. Also great if you check it out and let me know what you think. So I gave this talk at Observability Fest 2022, and after I was done, they generated this absolutely spectacular mind map of my presentation. This is essentially what I'll be talking about, and I'll show this again when we're done, and it will make even more sense then. Containers and orchestration revolutionized development and production, no doubt. But in a way, Kubernetes made debugging production issues harder than previously was. In the past, we had physical servers we could just work with, or even VPSs. Now we face much greater difficulty in this age due to 3 big challenges. The massive scale enabled by Kubernetes is a huge boon, but it also makes debugging remarkably difficult. We need new tools to deal with this scale. We now have multiple layers of abstraction to the deployment where failures can happen in the orchestration, container, or code layers. Each failure requires a different set of skills and solutions. Tracking the cause to the right layer isn't necessarily trivial. And finally, there's the barebone or lean container deployment problem when debugging. This is the first problem I want to focus on. We'll get to the other 2 soon enough. It's the problem of bare-naked container. We can connect to the barebone container, but we have nothing to do inside it. Nothing is installed. We can inspect logs, but that relies on luck. Furthermore, if your logs are already ingested by a solution like Elastic, you probably don't have anything valuable to do within the barebone container. kubectl debug solves these problems and can work even with a crashed container, or as we said, a barebone image. The kubectl debug command adds ephemeral containers to a running pod. An ephemeral container is a temporary element that would vanish once the pod is destroyed. With it, we can inspect everything that we need in the pod. Most changes we do in it don't matter. They won't impact the pod after we're gone. It works with barebone container. The way it does this is with a separate image, so we can have an image that includes everything in it. The container spun from the image is ephemeral and can include a proper distro and the set of tools that we need. kubectl debug was introduced in version 1.23, so if you're still in an older version, you will need to wait for that. If you use hosted Kubernetes, you need to check the version they use. Let's start with a simple demo. As you can see, we have here a few pods. We're experiencing an issue and would like to increase the logging level so we can better see what's going on. I can use exec and log in directly to the live pod. I log in with a proper bash shell. I'm sure most of you did that in the past. It's pretty easy. Here I can just use standard commands like cat and grep to check the logging level. This is all good. We can see the current level is at info. Unfortunately, I don't even have vim if I want to edit this file. Now when the container has apt or apk, and when the pod isn't crashed, I could in theory just apt-get install vim. But that's got its own problems and is a painful process. We don't want people in production just installing packages left and right, even if it's cleaned up, and the risks are sometimes too high. Pods shouldn't be touched in production once deployed. All the information and state of a pod should be described in its manifest, unless it's strictly stateful pod like a database, etc. So installing like this is problematic. Let's exit for a moment and try connecting again with kubectl debug. I'll use the busybox image in this case, and we'll see how that works. Notice this is the image referenced in the kubectl debug docs. So I'm connected to the pod again, or so it seems. Technically, I'm connected to a new ephemeral container and not to the pod directly. This is an important distinction. But as you can see again, I don't have vim or really any of the tools I would expect like visual VM, traceroute, etc. I can fix that. I can create an image that represents everything I need and package all of those tools that I need, then pass that image to kubectl debug and just use these tools. But here's the thing, I'm not unique. We're all pretty much the same. We all expect the same things in our debugging sessions. And that image that I can use, it's probably the same image that you would use. So why not have one generic image? This is where KoolKits comes in. KoolKits was created by Tom Granot of Lightrun. KoolKits is an open source project that includes a set of opinionated, curated, platform-specific tools for kubectl debug. So you can have everything you might need at your fingertips while debugging. So what does that mean? When you use kubectl debug to spin up an ephemeral container, it's built using a KoolKits image. Currently, there are 4 standard images. A Go image that includes tools such as Delve, pprof, GoCalvis, and many others. The JVM KoolKit, which includes tools like SDKman, JMXterm, Honest Profiler, Visual VM, and much more. The Node version includes NVM, NDB, 0x, VTop, and again, predictably, much more. And finally, the Python version includes PyEnv, IPDB, IPython, and again, you call it much more. But this is just the tip of the iceberg, as all the versions include the many tools you would expect in any proper debugging session, such as Vim, HTOP, and also have lots of networking tools like traceroute, Nmap, database clients for Postgres, MySQL, Redis, again, so much more. So let's continue from where we left off in the demo. We can disconnect from the current session and then spin up a new session with KoolKits image. Notice we can also use the shorthand KK command for many operations, which I don't use here, but you can see the syntax in the KoolKits docs. Specifically in this case, notice I used the JVM version of KoolKits, which I chose because I'm a Java guy. But if you're using a different environment, you can use what fits there. In KoolKits, pretty much every tool I want is already pre-installed as part of the image by default. This means we can just connect and everything is already there. Since we're all very similar in our needs, KoolKits includes the common things most of us need based on the platform or language. It has sensible defaults and comes with Ubuntu as a distro. This is important. You have a full distribution like you would have in a desktop or in a regular server. This is very helpful for debugging. So you get everything you need even when debugging a barebone container. Notice that thanks to kubectl debug, we have full access to the main application containers file system and the pod's process namespace. So we can do everything there while residing in a more convenient environment. It's having our cake and eating it. So just to finish the story from before, I can just use Vim to edit the file and change the logging level to error, which I can then confirm using cat and grep. I can also do a lot of other things, such as profile using a profiler, debug with GDB or JDB. I can use JMX-term to perform JMX operations, which lets you configure the way the JVM behaves in runtime, and pretty much anything I can do in a local machine. To give you a sense of what KoolKits installs, this is the list of packages for the JVM client. And this is bound to grow, as you can all submit pull requests with your favorite packages. This is just the JVM specific image. The other images contain similar tools at a similar scale, and you can get all of that thanks to kubectl debug and KoolKits. What if what we're tracing seems to be an application bug? This is a common occurrence for sure. We might not know it at this stage, but that might be the place we want to investigate. We can try using logs and probably should start there, but more often than not, the issue we need solved isn't logged. We can try using various observability tools. They're great, but not for application level issues. They rule for big picture analysis and container level problems, not for application level problems. We can use one of the debuggers in KoolKits to track it. That would only work if we know the server where the issue manifests, which we sometimes do know, but it's remarkably risky. Connecting a debugger to a production environment can lead to multiple problems. Stopping on a breakpoint by accident, using a conditional statement that grinds the system to a halt, exposing a security vulnerability. JDWP is the Java debugging wire protocol. There are several such remote debugging protocols we can use. It suffers similar issues of security and the problems that we have with JDB. Let's dive into this and let's try debugging with JDB, a Java program. So here's the first problem we run into with the debugger. We can't just start using it. We need to relaunch the app with debugging enabled. That means killing the existing process and running it over again. That might not be something you can just do. Furthermore, running in this mode is a big security risk. Notice I limit access only to the local server, but still, it's a big risk. Leaving a remote debugging port enabled in a deployed server code is considered a huge vulnerability. If hackers can ride a different vulnerability, they might be in a position to leverage this from a local system. Still, if we do this for a short period of time, this might not be a big deal, right? Right? In a different window, I need to find a process ID for the application I just ran, so I can connect to it. I can now type it into the JDB command, and now I'm connected with a debugger. I can add a breakpoint using the stop command. Naturally, I need to know the name of the class and the line number, but I can set a breakpoint to stop at. Once I stopped, I can step over like I can with a regular debugger. However, this is a pretty problematic notion on multiple fronts. First off, I'm literally stopping the thread accessing this application. That's probably not okay on any container you have in the cloud. There are ways around that, but they aren't trivial. The second problem is different. I'm old, so people automatically assume I love the command line, and I do to some degree, but I love GUI more. When I started programming, there was no option. We didn't have IDEs on the Sinclair, Apple II, or PDP. But now that we have all of those things, well, I don't want to go back. I programmed Java since the first beta, and this was actually the first time I used JDB. I'll use command line tools when they give me power, but debugging via command line, I just can't. The obvious answer is JDWP. We have a remote debug protocol that's supposed to solve this exact problem, right? But this is a bit problematic. If we open a server remote access port with JDWP, we might as well hand over the keys to the office to the hackers. Go right ahead, take whatever you need. A better approach is tunneling. During the age of VPS, we could just use SSH tunneling, like this. We'd connect to a remote host and forward the port where the debugger was running locally. Notice that in this sample, I used port 9000 to mislead hackers scanning port 5005, although it wouldn't matter because still it's SSH. We can do the exact same thing with Kubernetes, using the port forward command to redirect remote JDWP connection to a local host. Port forwarding opens a secure tunnel between your machine and the remote machine on the given port. So when I connect to a local host on the forwarded port, it seamlessly and securely connects to the remote machine. Once we do that, I can just open IntelliJ IDEA and just add a run configuration for remote debugging, which already exists and is pre-configured with the default such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost, even though my pod is physically remote. That's because I'm port forwarding everything. I make sure the right run configuration is selected, which it is. And now just press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. This is perfect, right? Not exactly. It's got quite a few drawbacks still. As we can see, there are so many problems in this process. First and foremost is the need to restart the process. We can possibly run with debugging turned on by default, but that's a huge, huge risk. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a railed system, and it literally fell into the ocean while he was stopped on a breakpoint because it didn't get the stop command. He was stopped on a breakpoint when it said start, and it didn't, and stepped over, and it didn't reach the stop command. So the rail system just kept going and fell into the ocean. I don't know if that's an urban legend or if it's real, but it's plausible, and that's what's scary. All remote debugging protocols are insecure, but I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there were CVs already about products that left it open. It isn't designed with security in mind. But it's also a stability risk. How many times did a debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables and the watch can cause unforeseen problems in some cases. But this is the absolute worst. Say your app has a place where it takes user credentials for login. Maybe a third-party library you use does that. You can still place a breakpoint there and steal user login details. Worse, you can elevate the permissions of your own user account because everything is writable. Just set a value of a variable to anything. This goes against privacy laws and is very damn likely. 60% of security breaches in organizations happen because of an employee that was disgruntled. There's often a misconception of security that targets the outside world only and ignores internal vulnerabilities. This just isn't true and isn't an option. We need to keep production locked down. And JDWP is the exact opposite of that. It keeps it completely open inside the organization and possibly outside of the organization. I didn't forget about this slide. This is an even more important aspect. Everything we discussed up until now assumed we know the exact container where the problem is happening. In real life, this is rarely the case. We can have thousands of containers in real-world deployments. How do you debug something like that? The debugger can solve the depth issue well. It can get deep into the source code and find a problem that's buried inside there. But it wasn't built for the scale of production, or for production itself for that matter. That's where developer observability comes in. We used to call this continuous observability, but developer observability makes more sense. It's a new set of tools designed to solve this exact problem. Observability is defined as the ability to understand how your system works on the inside without shipping new code. The without shipping new code portion is key. But what's developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? In practice, we add an agent to every pod. This lets us debug the source code directly from the IDE, almost like debugging a local project. To start, we need to sign up with a free Lightrun account at lightrun.com/free. Notice that Lightrun has a very generous free tier you can use to experiment and also use it in production. Pretty much everything I show here can be accomplished with a free account. I'll skip the actual setup since it's covered there and we don't have much time. You can check out the Lightrun docs for more detailed instructions on setting Lightrun in Docker, Minikube, etc. Unlike kubectl debug, we need to install the agent before the problem occurs. So if we do run into a problem, we'll be able to jump right in. Let's skip right ahead to a simple demo right in the IDE once the agent is set up. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are a prime number or not. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the result at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include anything, any type of expression I want, as the value of the variables that are included in this expression. I can also invoke methods and do all sorts of things, but here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show as a marker on the side. Once the log is hit, we'll see the log appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice the log point is paused due to high call rate. This means additional logs won't show for a short amount of time since logging exceeded a threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. Let's move on to a different demo. This is the Node.js project demo that implements the initial backend of a microservice architecture. This is the method that gets invoked when we click a movie and we want to see the details. This time I'll snapshot. Some other developer observability tools call this a capture or non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now I'll just check access the portion in the front end that triggers this code. And now we wait a second and the snapshot is hit. So what is this snapshot? It gives us a stack trace and variables, just like the regular breakpoint we all know and love. But the code, but it doesn't stop at that point. So a server won't be stuck waiting for a step over. Now, obviously you can't step over the code, so you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. But this gets much better. This was a relatively simple demo in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here I have a problem with the request. One specific user is complaining that the list on his machine doesn't match the list that his peers are getting. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So a solution is to use a conditional snapshot, like you can with regular breakpoints. Notice that you can define a condition for a log and for metrics as well. This is one of the key features of continuous observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition that we already have that we have here. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I used the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often a good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user to hit that snapshot. This is the point where normally you can go make yourself a cup of coffee, or even just go home and check this out the next day. That's the beauty of this sort of instrumentation. In this case, I won't make you wait too long. The snapshot gets hit by the right user despite other users coming in. This specific request is from the right user. We can now review the stack information and fix a user-specific bug. The next thing I want to talk about is metrics. APMs give us large-scale performance information, but they don't tell us fine-grained details. Here, we can count the number of times a line of code was reached using the counter. We can even use a condition to qualify that, so that we can do something like count the number of times a specific user reached that line of code. We also have a method duration, which tells us how long a method took to execute. We can even measure the time it takes to perform a code block using a tick-tock. That lets us narrow down the performance impact of a large method to a specific problematic segment. In this case, I'll use the method duration. Measurements typically have a name under which we can pipe them or log them. So I'll just give this method a duration a clear name. In this case, I'm just printing it out to the console. But all of these measurements can be piped to statsd and Prometheus. I'm a pretty awful DevOps, so I really don't want to demo that in this case, but it doesn't work. But it does work if you know how to use these tools. And I did demo them when I had some help from a guy that actually knows how to do that stuff. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of the method. The last thing I want to talk about, it brings all of this together, is tags. We can define tags to group agents together, such as production, green, blue, Ubuntu, etc. Every pod can be part of multiple tags. Every action we discuss today can be applied to a tag, and as such can run on multiple machines simultaneously and asynchronously. This solves the scale problem when debugging. So let's go back to the list of drawbacks we had with debuggers and review it. You can keep an observability agent running all the time since it's designed for this case. It won't be a security risk. It won't have a problem with running all the time. And the reason behind that is that the agent doesn't connect to, you don't connect to the agent. The agent connects to the management server in a developer observability tool. That means you don't actually open any port, and everything is completely segregated through a management server. So it's an observability solution. It's not a standard debugger. And as such, it's far more secure. And this goes for every developer observability solution from Lightrun or pretty much any other I'm familiar with. There's extra security capabilities that we can talk about that apply to Lightrun specifically. We don't have breakpoints. Snapshots don't stop. So if you need something like a breakpoint but can't use it in production because it's a problem, A, you don't have the problem of accidentally using it, and B, you can actually use it and get all the data and benefits of a breakpoint without the actual problem of stopping. They are secure by design, and everything is read-only. As I mentioned before, and I might not have mentioned it clearly enough, everything that you add into the agent is sandboxed. If you remember before, we saw a log and we saw it getting swallowed and not printing out after a while. And the reason for that is that the code in the log runs within a sandbox. So the sandbox prevents it from taking up too much CPU. If it takes up too much CPU, the log is paused. If it tries to write or invoke a method that triggers a write, then it won't work. It will disable the log. And this is exactly it. It won't slow down your server. It won't crash it. And that's part of the guarantee of the sandbox where things run. Notice that sandboxing is a feature of some developer observability tools and not of all of them. And it is a feature of Lightrun. You can destroy the server, and it will throttle your CPU, as we said. So it's not a stability risk either. And as we said before, some services like Lightrun support features like PI reduction, which removes private information from the logs. Like, for instance, if a user wants to print out credit card numbers, or does that by mistake. So, for instance, if one of your developers logs a user object into the system log, and if that user object has a credit card number cached within it by mistake, which normally you shouldn't do, but it's possible, people make mistakes, then this credit card number will go into your logs and will be in violation of laws, regulations such as GDPR and things like that, and also in violation of credit card regulations from all the CCV, if I remember correctly, the organizational name. It will be a problem for you. So here we have a simple solution of PII reduction, which detects patterns like credit cards, like social security numbers, things like that, and automatically removes them from the log. So you won't accidentally print out personal identifying information of the user. And this is really important legally. Furthermore, there's block lists, which let you block the developer from adding actions, that means logs, snapshots, etc., into specific files. So if you have, and you can use star notations and things like that to make it all very generic. So a good example here would be blocking users from adding a breakpoint into the login code. So a person can't log the credentials, or any file where credentials might be exposed, where payment details might be exposed, things like that. You can simply block the files and don't let developers place a snapshot or a log within those files, and this will increase your security. So in closing, I'd like to review some of the things we discussed today. kubectl debug made debugging crashed pods possible. It also made it possible to debug a pod based on a barebone image. KoolKits made the kubectl debug easier to use with pre-installed tools. Debugging an application in an existing container in production is difficult and risky. Finally, Developer Observability made deep, secure, read-only, real-time debugging at scale easy. Thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions, and also feel free to write to me. Also, please check out talktotheduck.dev, where I talk about debugging in depth. Check out lightrun.com, which I think you guys will like a lot. And if you have questions, my email is right here, and I'll be happy to help. Thank you so much.
Perfect. Thank you very much, Shai. That was Very insightful look into some developer observability and the new open source KoolKits project as well, which is great. So for anyone,
don't forget kubectl debug.
And can't forget that. So yeah, anyone with questions, please get them in. I can see a couple have come through already. So we'll start with the crowd questions, and then from Thomas, and then move on to some other ones that have come through before as well. Does Lightrun work well with VS Code and a .NET AWS cloud setup?
Great question. It works great with VS Code. There's a plugin for VS Code and vscode.dev, so you can debug directly inside your Git repo and things like that. Really cool. .NET is the next platform coming in support. We support JVM languages, pretty much all of them, Python and Node, and .NET is right on the cusp of launching. So chat in the website and talk to the guys, and maybe you'll get into the beta early on, because it's literally launching now. It's into beta.
Perfect. And then a follow-up from Thomas as well. Are you able to comment any further on how Lightrun compares to other developer observability solutions?
Great question. So that's the field is changing a lot. So everything I say right now might already be out of date because I can't keep up with everything. There's lots of tools coming out and lots of changes coming around. The big differences between all of these tools are the following. Some work cloud only as a SaaS or on-premise only. Lightrun specifically works with both. So you can get an on-premise server deployment or a cloud SaaS solution. And when I mean SaaS or on-premise, I mean the agent that runs on your physical server, that's where the logic and everything happens, needs to connect to a management server. And that helps keep your production segregated from the IDE. So you don't just open your production to the web, and like a developer shouldn't be able to connect directly to the server. So the way this works is through the management server in the middle. That's what makes Developer Observability secure. And if it's in on-premise or in the cloud is a major difference. Second one is, does it work through the IDE? Which we do. We work through the IDE, through the web. We now added VS Code.dev support, so we support the web. Some tools only work through the web, and some tools have only CLI. We have a CLI as well. We don't promote it as much because it's, I think the IDE experience is better, but there's a CLI as well, and some people use it. Another difference is the various languages supported. Some companies also support languages such as Go, which we don't support, and Ruby and stuff like that, which is great. We hope to get there. .NET also, we don't support it yet. We will support it soon. As I mentioned before, we support JVM languages, Python and Node, and it's moving in that sense. There's also a difference in performance and in sandboxing, and these are really important. So sandboxing isn't supported by everyone, and it's super important. We have that. And performance varies based on the language and the runtime. You need to benchmark that. We benchmarked our own, and as a vendor, trust me or don't, we do really, really well in that sense. But don't take my word for it. Just download everything for free and compare, check it. I'm sure we'll do well.
Yeah, wonderful. That's extensive answer there. I'm sure Thomas will be very pleased with that. Thank you very much, Shai. And then some more questions, I guess, about you specifically. How do you sort of split your time when going about a debugging process?
How do I split my time when debugging a process?
When you're debugging, sorry.
How do I split my time when debugging a process? I'm not sure I follow that.
No problem. We'll ignore that first question then. And then I guess we've probably got time for one more question before we wrap for lunch. Got someone who apparently heard one of your talks before and would like to know how you got into public speaking around a topic that you clearly like.
Well, that's a very long answer. I'll try to abbreviate it by first saying that I'm old and I've been doing this for a long time. I'm older than I look, some people would say. because I was teaching and speaking quite a lot and programming, I think, since the early 90s. And then I formed my own company, and I worked a lot with the community and things like that, and open source, and in the mid-late 90s, and sort of rolled into some talks in local venues, small things initially, and mostly teaching. And then when I worked at Sun Microsystems, they very much encouraged people to submit talks to Java 1 and conferences like that. And that's sort of when I started submitting and getting accepted for speaking. And then it sort of became like an annual thing of flying to all the conferences and doing all of that. And I did that for years and years. And I stopped like 7 years ago, when my second born was born, because too much travel. And just recently got back to developer advocacy in August last year. And thanks to COVID, actually, because you don't need to travel as much.
Absolutely.
And yeah, that helped me, although I still try to travel once a month at most, to keep it calm. And that's sort of it. As a developer advocate, that's part of the job, to do that. I've always felt comfortable in front of a crowd. I was always an entrepreneur. So I'm used to pitching and talking and doing presentations. It sort of becomes second nature after you practice it for quite a while. I actually have on my LinkedIn, if people want to connect to me there, I think a post from a couple of months ago where I talk about how I was a terrible speaker when I started and how I improved, because I think up until 10 years ago, I was awful. And I've been speaking and got amazing ratings and everything. I got the Java 1 Rockstar, I think, and things like that before that, but I was terrible.
Mm-hmm.
And it's a constant matter of improvement.
Perfect. Well, yeah, thank you very much for that. That's excellent. Well, yeah, thank you very much for your time as well. If anyone has got any additional questions, please reach out to Shai through either his email, Lightrun, or social media.